Locate your note, solving absolute value inequalities. The process that we're going to use to solve inequalities is very similar to that what we use to solve equations. We're either going to have a greater than question, which is going to end up in the form of ax plus b greater than c, or ax plus b less than negative c. We're going to have a less thans, which are going to be sandwiched in between the negative and the positive. So the first thing we're going to do, just like we did with the equations, is isolate the absolute value. And then we're going to look at if we have greater thans or less thans, and that determines if it's an or, greater for or less thans for ands. All right, let's look at an example. So the absolute value of x plus 4 is greater than or equal to 6. Well, the first step you want to do is to isolate the absolute value. That's already been done. Greater is an or. So when we set this problem up, we're going to go x plus 4 greater than or equal to 6, or because we have to also consider the fact that the absolute value could have a negative number inside of it, and a shortcut for this is just go x plus 4, flip the inequality, and negate the number. So we have to consider the positive in the absolute value and the negative in the absolute value. Now simply solve both inequalities. So in the first one, we're going to subtract 4. So negative 10 minus 4 is, negative 6 minus 4 is negative 10. Or subtract 4 again. 6 minus 4 is positive 2. Now when you graph an or, it's going to look like oars on a boat. These are both closed, so we're going to go negative 10, it's closed. It's less than, so it's going to the left. And then 2, it's also closed, and it's going to the right. All right, now we have a less than or equal to. Here again, notice that the absolute value has already been isolated. So we can break it into two equations. But here, since it's a less than, the shortcut for this is to sandwich it in between the negative and the original. Now this is a compound inequality, and we're going to solve for the middle out. So that means we're going to subtract 1, and we also have to subtract it from both ends. So we're going to end up with negative 10 less than or equal to 2x, which is less than or equal to 8. Next, working from the middle out, we're going to divide everywhere by 2. So negative 10 divided by 2 is negative 5x, and then positive 4. So an and is sandwiched in between the two values. Here again, we're closed at both values, and anything in this interval is going to make our inequality true, between negative 5 and 4. So that's why sometimes you may see the answer written as an interval. All right, here we got to do a little bit more work. We got to isolate that absolute value. So we need to subtract 2 first before we break it apart. So 8 minus 2 is 6. All right, now we can break it apart. Is it an and or an or? It's greater, so it's an or. And you must have that word as part of your solution. All right, so leave it alone, the original. And then we're going to flip the inequality, negate the number. Solve both. So add 11, we get 5. Or add 11 and we get 17. So when we graph, this time we're open at 5 and we're going to the left. And we're open at 17 and we're going to the left. All right, absolute value has already been isolated. It's a less than, so it's an and. We're going to sandwich it in between the negative number and the positive, or the original. All right, here again, compound inequality, working from the middle out. So subtract 24. So we get what? Negative 35 less than or equal to negative x, which is less than or equal to negative 13. All right, working from the middle out, divide by -1. Don't forget to do both ends. Right, negative 35 divided by -1 is positive 35. Now remember, when we divide by a negative, it flips over our inequalities. And negative 13 divided by -1 is positive 13. Now, when you write a compound inequality, you never write it with greater than. So we're just going to use symmetric property and flip this entire thing over. Graph it, 13, 35. We're closed at both of them, and it's any value in between the two. All right, absolute value of 2x plus 5 is greater than or equal to -2. Greater is an or. So we're going to write the original. And then flip the inequality and change the sign. All right, let's solve both. Subtract 5. 2 minus 5 is -3. Or subtract 5, 2x. -2 minus 5 is -7. Divide by 2, x less than or equal to -3/2, or x greater than or equal to -7/2. All right, let's graph this. -3/2, closed, so it's going to the left. -7/2, it's also closed, and it's going to the right. Notice how this is covering the entire number line. So what do you think that means? Well, hopefully you realize that it's all solutions. So all reals work here, or between negative infinity and positive infinity. So any number you put in for x will make this inequality true. And think about it. Remember that an absolute value is always positive. And isn't any positive number greater than or equal to -2? So here again is an example. When you have negatives and absolute values, watch out. Something unusual may happen. Let's check out another example. All right, absolute value of 2x plus 5 less than or equal to -2. Well, you see a negative there, so maybe say, well, something weird might happen again, something unusual. All right, less thans or ands. So the typical way we do a less than question is we sandwich it in between the original and the opposite. Well, you might say right there that this doesn't make any sense. Let's break it up into two inequalities and show you why. Let's solve the 2 less than or equal to 2x plus 5 and the 2x plus 5 less than or equal to -2 and see what's happening. All right, so let's subtract 5. We get, what, -3 less than or equal to 2x. Divide by 2, so -3/2, is less than or equal to x. All right, we like to have our x on the left-hand side so it's easy to graph. So symmetric property again, flip this whole thing over. And, all right, subtract 5, you get -7. Divide by 2, we get -7/2. So let's graph both of these. So we have that x is greater than or equal to -3/2, and x has to be less than or equal to -7/2. Well, notice here there's no intersection. Ands have to intersect. They have to cross each other, and there's no intersection here. So that's why our answer here is the empty set, or no solution. Because there's no single value that's going to make both of those true. And here again, think back to the original. If you've got a positive number, that's never less than a negative number. So that's why it's no solution. So hopefully you'll recognize it from there. So warning, anytime you see negatives in absolute value, watch out for unusual circumstances. All right, so here's the summary. If you have any questions, please ask.